Welcome to Learn Programming in Java Streams. Now, some courses are going to be very generic and allow you to use command line, all various IDEs. This course is going to focus primarily 100% on IntelliJ. Hey, we don't have a lot of money, so I'm going to recommend I think the best value books out there for you. If you want to follow along with these books in the course, they will align very well. If you're kind of on a shoestring budget, the PDF version of the Java 5 book from Bruce Eckel, great value for the money. It's basically free. You want to get the hardcover edition, that's on Amazon. You can click on the link there. It'll take you to the Amazon website. Now, in terms of just a Java 8 book, maybe you can get one used. Maybe a friend of yours has one. Bruce Eckel on Java 8, I think the best book out there, just in general, in programming, his style, his wording, it really explains it all well. So if you're kind of like a book person, you want to read some of his chapters, read and watch my course, that's a great way to learn the language. Okay, once again, I'm Hugo Scavino, a little bit of self-promotion here. Been doing this for 30 years. I started doing Java since the beta, so it's been a long time. I primarily used what I needed to use to get my job done. I've taught this class in various countries, UK, France, tons of Fortune 500 companies out there. I've been a senior software architect with companies like DTC, Penske, HSBC, and lots of government agencies. I've been doing this a while, basically. If you want to know more about me, check out the link to my LinkedIn page and connect with me. So let's get on to the next slide. Okay, what's required? Really, you just need JDK 8. Now, I know most of you you're running 11, 17, 21, and might be a little bit confusing, but this course really focuses on the fundamentals. The fundamentals are all in Java 8. We're not going to talk about Java 5 or anything earlier than that. Of course, you can install later or newer versions of Java 11. You can get them from Amazon, Oracle. You can also get them from the open source. I'll let you Google that and figure out how to install the JDK on your environment with a Mac or PC or Linux. This course is not going to teach you how to do that. Quick Google will let you install the JDK. I recommend installing the latest version. This course is not going to go over the newer features. We're just going to go over what's fundamentally in JDK 8. Now, some courses are going to be very generic and allow you to use command line, all various IDEs. This course is going to focus primarily 100% on IntelliJ. I think it's the best IDE out there. If you've never used an IDE, IntelliJ is the one I've been using for the longest time. There's really no need to try to make this course available for all these other environments. You can port it if you want. There's Community Edition. It's free. It's awesome. Just download it, install it. So these two are the requisites. If you're not sure how to install JDK 8, please take some time. A couple of YouTube videos will get you installed right away, and then install the IntelliJ Community Edition. If you have the paid edition, great. That'll work too. We're not going to use any of those features though. So let's get that all installed and see you back in the next slide. Hey, we don't have a lot of money, so I'm going to recommend I think the best value books out there for you. If you want to follow along with these books in the course, they will align very well. If you're kind of on a shoestring budget, the PDF version of the Java 5 book from Bruce Eckel, great value for the money. It's basically free. You want to get the hardcover edition, that's on Amazon. You can click on the link there. It'll take you to the Amazon website. Now, in terms of just a Java 8 book, maybe you can get one used. Maybe a friend of yours has one. Bruce Eckel on Java 8, I think the best book out there, just in general, in programming, his style, his wording, it really explains it all well. So if you're kind of like a book person, you want to read some of his chapters, read and watch my course, that's a great way to learn the language. All right, that Java 8 book, though, does have references to the newer versions of the language, so you can learn the basics and the concepts, but also learn some extra things while you're at it. Now, if you want to get the latest and greatest in the language, I do like the Head First Java series, Brain Friendly Guide. It's the 3rd edition. It does have a lot of new things in it, but really I would like to focus on the fundamentals. Once you have those concepts, the new concepts kind of build on top of that. So these are my recommendations for textbooks. They go from free to kind of medium to the latest version. Leave it up to you. you want to read those chapters and watch my course, great way to learn the language. Okay, so what are we covering actually? Not beginner stuff, not advanced stuff. Intermediate is what I call the streams package. So the streams is a way to provide functional programming. Remember the functional programming chapter we went over? It's going to pay off now. This is a functional programming approach to processing collections. Collections, you remember, are array lists, sets, and queues, things we learned earlier. So we're going to put it together and see how we can use that data in a concise, and I mean really tight format. It's in a declarative way. Some of these key characteristics, of course, are how declarative it is. It focuses on what to do than how to do it. The lazy valuation allows us to be more performant, and we're almost going to exclusively focus on the pipeline model. That's where stream operations can be chained together to form a processing pipeline and at the end produce a result. Choo-choo! Let's break down streams into basically 3 parts. There's the source. Generally, you don't really produce the source. You get the source from something else, like a collection, an array, a file, or some I/O channel. So you're getting data from another repository, maybe a database, maybe a list. So you're not always producing the source, but maybe you are. But there's a source. Then you're going to do things to this source using these lazy operators that we talked about that will transform the stream into another stream. So it's not mutating the data, okay? It's transforming it into yet another stream all by itself. So the previous stream is left alone, but then now we have another stream, like a map filter. We do this as often as we need to until we get to the very end. And that's a terminal operator. What's a terminal operator, you may ask? At the end, we produce the actual result or the side effect. All right, so we have a source, we do some processing, and at the end we get a result. Now, the streams that we're going to work on are sequential streams that process data in a single thread. You can do this in a multiple thread. It's really cool, it's really fast and well-performing, but that's not in our scope. So for all intents and purposes, we are doing everything in a single thread. Why should you care? The code is readable. It's better productivity because we're kind of relying on functional operators that can simplify common tasks like filtering and transformation. You don't have to do your own for loop basically. And again, if you're in the world of threading, the parallel processing is pretty neat. So it's better code, less code, maybe not as readable to some of you who have been doing this for a while, but it is an upgrade. Streams are not a panacea. They're not great we don't use them everywhere in all places. They're mostly great for the things that they do, okay? So if you're changing state, for example, it's not a great choice. As mentioned, there is a learning curve. The more you do it though, the better it gets. If you're brand new on the team, you haven't done this before, it's worth kind of go over in this chapter and maybe some other chapters in other places to kind of get used to it. The one big issue I have with it, of course, is it's difficult to debug. It's easier to put a system.out in a for loop. You kind of figure it out, straightforward. You don't really have to go through a lot. You don't have to add something new. But there are some ways to help with debugging, and I agree it can be a little difficult at the beginning. Okay, what are some of these operators you've been talking about? All right, assume we have a source, some kind of list, an array list, a set, something, okay? So we have a list of things from a collection. Well, what if we want to filter it? What if we want to transform that stream to another stream? What if we want to turn that map into a single stream? All right, we literally take a map and make it into an array. What if we want to remove the duplicates? What if you want to sort them? Maybe limit it to certain elements, and maybe you want to skip certain elements. So these are methods that you've probably been doing on your own, or you had little utility functions. Well, now they're built into the language, the part of the Streams API, and you don't have to start from scratch. You can just start using them now, and everyone knows what they are, and so less things to document. All right, now I get some feedback on this. Well, I've done processing. What now? What do I do with it? Well, these are the terminal operations, okay? Good old for each, you know what that is. The collect is to collect them in a way, in a form that you want. Maybe reduce it. You can always just count how many items that you got. Maybe that's all you care about. Maybe you want to find the first one that meets a certain criteria, and then you're done. Or all or any that or none that match this predicate. So there are ways that you of course have to end the stream. The IDEs will help you if you don't end it, because it's just going to be a stream. You're like, now what? I'm hanging here. I have this stream. What should I do with it? But you do need to terminate it to have something return of useful value. Okay, let's take this one step at a time. Here's a quick example. All right, if you want to pause for every line, great. So let's just create a bunch of, let's just seed this stream with a random class. And not really important, but you just have a random bunch of integers. Okay, so we're going to now do a range from 5 to 20. All right, so between starting at 5 and ending at 20, we're going to have some random numbers. Then we're going to get the distinct list from that set of random numbers between 5 and 20. We're going to get no more than 7, and then we're going to sort them. Numbers and primitives don't need a special algorithm for sorting. And then, as the terminal operator, we're going to loop through each one and print it out. You can run this code in your compiler. It'll be different every time you run it because of the random operator. But these are the steps. You have a source, which is a random. You have some operations that go from stream to stream, the chaining, the Choo-Choo part, and then the last part is the termination, which is the for each. All right, compare that to this code, which is the same code. All right, there's your random. Okay, now I gotta get a tree set of all things. How often have you used that? I'm going to, while that limit is less than 7, remember the limit? I'm going to get the random integers between 5 and 20, and then I'm going to sort them in that second to last line, and then at the end I'll just print them out. Compare that. How readable is that? It's kind of, you're kind of deducing the logic from inside out versus one line at a time. So compare the two. You might like the second one because, hey, I've done it before, and I have utilities to do this that I've written, but I think you really want to go the way of streams. Okay, I don't use this a lot except for examples, but you can create your own stream and stream.of. So you here, there's 3 movies that I created real quick, and then I terminate them with the for each. I can create a stream of 3 strings and by 5 numbers, and again I terminate them with a for each. So you can create your own stream. Usually you get a stream from something else. All right, what's that something else, you might ask? Well, here's a list. All right, so here's one of my favorite movies, Conan from 1984, Godfather, The Godfather Part 2. So you can imagine maybe you have a lot more than just 3 movies in your list, but you can do a .stream on the array list. So that's been added to the interface for array list. It's backwards compatible in that the old array list from previous versions didn't have it, and that's okay, but the new one does, but the stream API is only in this one, so it works out. So if you weren't using streams, you don't want to use streams, that's fine. You can keep using it the way you always have, but ArrayList now has a .stream, which is a production or a producer. Then now you can do something with that. Here's yet another example. All right, the orders.stream is getting a stream from the orders. I have an order for customer 1, customer 2, customer 3. All right, then I'm going to map, okay, the total from each one of those. By the way, the order class has a total. I'm going to map all that and call the .sum on that. So I'm going to get the grand total. Think about that. No for loop, no intermediate I or other variable. I am using just plain old streams to grab all my orders, take the total, which is over here, right? 10, 12.50, 99.45, and then I'm going to sum them, all right, by having this map to double. This is a double. The map is going to map all the individual totals and then sum them. So at the end, you can do the math here. You get the grand total of all the orders. No for loop required. How about that? All right, your next question is, what about my friend the array? I mean, an array is pretty primitive. It's not exactly a primitive, but I mean, can I do streaming with that? I mean, I'm used to the for loop. That's an enhanced for loop. That's kind of cool. That started in Java 8. But guess what? Arrays.stream, give it the raw array, and you got a stream, and then you can terminate it with the for each. So even your plain old arrays can be used with streams. Some of you may be peeved by not having a for loop. Listen, I love the for loop. I don't get you people, because I used to do system.out, and so I can see it on my console, so I can see if the total is working, right? They have peek now, so you can use this peek to see what's going on intermediately, if that's a word, while it's doing the sum. All right, so it will print out using the O over here and O over here for O total. All right, print these out if you really need to see what's going on in the summation. Once you get used to it and you give up a little bit of control and just know that it's going to work, you don't need to do this as often, but it's available. Okay, now hold on. You're wondering, well, all you've done is make my for loops better. I could have done this before. Why do I need this? Check this out. All right, your class, maybe you did have a comparator interface for your movie class, but what if you want to have different ways to compare your movie? All right, maybe you want to compare the movie by, I don't know, the ID, or compare them by the string name or the year. Well, you can only implement one comparator interface, but with the streams, all right, here's a stream from my movie list. I can give it a comparator. I can say compare movie with movie ID and then sort them out. Now, remember where the comparator is, that it will compare two values and say they're the same or less than or greater than. Okay? We don't want to talk about the comparator right now, but what I want to point out is that you can give it, and you can give the sorted an algorithm and compare the way you want. And if you want to do it differently, you can do it differently without modifying the movie class. So the movie class can be compared, can be sorted based on whatever rule you want outside of the movie class. Pretty neat, huh? Okay, how often do you want to flatten out a list? What if you have a list of lists, but you really don't want them parsed, or you don't want to manipulate them as a list of lists? You want them as just one list. Now you can do some clever algorithm to sort them or change them, or you can just flatten it. Okay, so here's my stream of list of list, and now I just want to make it a flat map. Okay, so it flattens each inner list into a single stream, and it comes back out as a flattened list. So now I have a list of strings. So it's apple, banana, cherry, dog, elephant, fish, and goose. Now it's just one list of strings that get printed out here. Pretty neat, huh? Things keep getting better. You can do an all match, an any match, a none match. So give me all of these that match if these are true. Give me if returns true if any of the stream elements are true. So the first one is that they all have to match. So if everybody in that stream has to match this predicate. So if it's something that's greater than 20, then everybody in this stream better be greater than 20. If you say any match, you say, well, anybody that or anything object that is greater than 20 or has an attribute that I use as a predicate that's greater than 20, then that's good enough. So it's either they're all match their predicate, any one of them match their predicate, or here's the negative one where I don't want any of them match that predicate. And if that's true, return true. So you can do matching now on these streams without having to do any new logic on your end. Okay, let's go through some demos. You can come up with as many permutations as you want, but let's take a look at my list. These are the years that I have, all right? 72, 74, 2008, 2024. All right, imagine it's a bigger list. Now, here's an any match. Is there anybody out there that has a year 1970 and greater? If so, then that will return a true. Okay, and actually it does, because they're actually all greater than 1970. So as soon as it gets to the first one in the list, whatever that is, it'll come back, yep, at least one of them matches, so we're good. Look at this all match. Are all the movies equals to 2024? Remember, you can do whatever operator you want here. Are all the movies 2024 movies? Are these all movies that exist in 2024? The answer to that is no. Only one of them is. What these other guys are not 2024, so this all match is false. Now, here's a none match, which is kind of a double negative. I don't want any vintage movies in my list. Are there any movies that are, I want, as long as none of them match this, then that's true. All right, so this is older movies, and yep, none of them are old movies from anything before 1950, so that returns true. So, okay, remember, none match. All right, so no vintage movies. There are no vintage movies. That is true. All right, sometimes you just want some metadata. How many are in there? What's the max? What's the min? All right, so that's available too. What's the first one in the stream that matches this criteria? It'll get you that, or an optional empty. Okay, find any of them that meet this criteria, or you get an optional empty. So you can select items from a stream using some of the find methods. I really hope I've given you kind of a high-level overview of streams, and we could do examples after examples all the time. But now that you've done the chapter with lambdas and the functional programming, I think this makes more sense now. The library is concise. There's so much you can do with it. I could have given you pages and pages of operators and terminators, but I want you to look at them and ask yourself, if I need to do even an intermediate or a basic kind of looping or other kind of logic or finding or filtering or maxing or any kind of metadata on a list, there's probably a streams API method for you. So that's what I like about streams, and that's the end of the chapter. Thanks a lot.
Bajaría sin pensarlo dos veces. No matter the time, no matter the place. Te miraría perdiendo